Welcome to Algebra 1, Semester 2, Unit 9, Section 10.6. In this section, it's our last section of this unit, we are solving quadratic equations by using the quadratic formula. I have a way that students have shared with me that's easiest for them to remember this. It's a cute little saying. The quadratic formula looks like this. It's x equals negative b plus or minus b squared minus 4ac over 2a. And students really struggle to always remember that. But listen to this little story as I point out where I get the parts of the story. It's in your notes, so just take a minute to think about this. You will be expected to memorize the formula. It will not be on the test. So here's the formula, quadratic formula. There was a negative boy, negative b, that could not decide, plus or minus, whether or not to go to a radical party, radical, or b square without 4 awesome chicks, because it all gets over at 2 a.m. Okay? So basically, these are problems that usually you have trouble finding an answer for. They're difficult to try and complete the square because they don't have a 1 as their leading coefficient, so we can't use that. And they're just not factoring, that kind of thing. You could use it on all problems. The quadratic formula will work for anything. Let's just practice writing the formula. So every time you write it, say the saying. A negative boy could not decide whether or not to go to a radical party or b squared without 4 awesome chicks because it all gets over at 2 a.m. Okay? Now, we need to come over and write this in standard form. 3x squared plus 5x. Get rid of the 8 on this side and bring it into standard form, so it would be a minus 8 equals 0. Here's my a value, my b value, and my c value. So to plug it in, I would write negative 5 plus or minus radical 5 squared, 25, minus 4 times a times c, negative 8, all over 2 times a. Okay? Try to make this one a little more roomy so that you can see it. We convert this to standard, 2x squared minus x, would subtract x from each side, minus 7 equals 0. Here's our a, our b, and our c values. Our formula, again, a negative boy could not decide whether or not to go to a radical party, b squared, without 4 awesome chicks, because it all gets over at 2 a.m. Okay? Now we plug it in. Negative b, well, it's already a negative 1, so it's a negative 1 plus or minus negative 1 squared is 1 minus 4 times our a is 2, our c is negative 7, it all gets over at 2 times 2. Okay? Go ahead and turn off the video and try doing these next two without my instruction, and then turn it back on and see if you have them correct. Okay. There are the answers that I get. The only tricky part, make sure that you brought this -1, got rid of it there, left it equal to 0, and have a +1 here. The other tricky part is remembering that the negatives come with the values, so that's a -8. And down here, this would be a -5 coming into this equation, or that expression. Okay, now we need to use the formula to actually solve. So we go ahead and we use it again, a negative. Well, just a minute. Let's get this in standard form. 3x squared plus 5x minus 8 equals 0. Now, a negative boy, so it's -5 plus or minus radical b squared. 5 squared would be 25 minus 4 times a is 3 times c is -8. All over 2 times a is 3. Now we go ahead and we work this out. We have -5 plus or minus 25. -4 times 3 would be -12. -12 times a -8 would be a positive. And then you may have to go off to the side and do that. 12 times 8, 96. A positive 96 over 6. Okay. Well, 25 and 96 we need to add. That would be 11. 12, so it's 121. So we have a -5 plus or minus a radical 121 all over 6. Well, you should know, or you're going to know right now, from our memorized perfect squares, 121 is which number? What two numbers multiply to be 121? And hopefully you remembered that it was 11 times 11. If not, remember it now. So we have -5 plus 11 over 6, or -5 minus 11 over 6. -5 plus 11 would be a positive 6 over 6, which is equal to 1. And then -5 minus 11 would be a -16 over 6, which could reduce to 8 over 3, -8/3. Okay? Now, we've really squeezed out this problem, so we'll do this in a warm-up, and you can write it down in your notes on a piece of scratch paper. We'll do it tomorrow in the warm-ups. So let's go over to this one. We'll spread it out a little bit. It's in standard form, so our negative b would be a -8 plus or minus b squared would be 64 minus 4 times a is 1 times c is 16 all over 2 times 1. So -8 is +8 plus or minus 64 minus, well, 4 times 1 is 4. 4 times 16 is 64, so we have 64 minus 64 there. All over 2. So we have 8 plus or minus 0, because the square root of 0 is 0, all over 2. 8 divided by 2 is 4. Only one answer there. I bet you can even picture that in your mind, what that graph looks like. We'll talk about those tomorrow. The last page here, I'm asking you to determine which method you should use to solve this. Well, the first thing that I want to make sure that you realize is the quadratic formula is used when we can't factor, usually, and especially on this page, because honestly the quadratic formula could be used at any time to get the answers, but I want you to get good at factoring and at using the square roots. Square roots we use when it's a value and a c value and nothing else. So in this case, we could go 10x squared equals 7, x squared equals 7 over 10, square root, and we get that x equals plus or minus square root 7 over 10. So that one we use the square roots with, because it was just the x squared and then a constant. Do you see any others on this page where it's just a square and a constant? If you said number 5, then you're correct. That should be labeled square root. That would be the method to use there. Now next, we have factoring. On the rest of these, you should try factoring, and if you can do it with factoring, then that's what you would use. If it's not factorable, and you can't complete the square, then you use quadratic formula. So when we try to factor this one, we can factor out of 4x, leaving x plus 1, and we see that we factor that one. Because now we can set each part of that equal to 0. On this one, we'd have to play the x game. We have negative 4 times 5 is negative 20. What two numbers multiply to be negative 20 and add to be, actually they would have to have opposite signs because they're multiplying to be a negative, so they would have to subtract to be 9. If we think of our factors of 20, we have 1 and 20, they subtract to be 19, 2 and 10, they subtract to be 8, and right there we've gotten smaller than the number that we need. So we know that this would be quadratic formula. The next one, x squared plus 6x, always bring it over for a trinomial, minus 5 equals 0. Well, can we think of two numbers that multiply to be negative 5 and subtract to be positive 6? The hard part is that they subtract to be positive 6. It's got to be a negative and a positive. If you were thinking 5, it subtracts to be 4. So we see that we can't factor that way, but we could, in fact, do completing the square on this one, couldn't we? We could take half of 6 and square that. So completing the square should be an option here that we have, and I'll make sure that it is on your exam. Okay, the next one. Could we factor to find this? Do we have two numbers that multiply to be negative 6, so positive and a negative, and they add to be 1? I say yes, 3 and 2 would do that. So that one is factoring. Okay, that is the end of that section and the end of that unit. Make sure before you turn in this that you have completed these transformation activity pages on the back of this. And you should have done a couple other activities in class. Make sure and check with me that you've done everything that's needed. Thank you very much. See you in class.